Kamusta? It's first time I'm here in the Philippines for ROOTCON, and I really thanks Jayapurla to invite us as well as it gives us a nice opportunity to present over here. So my name is Anomaly, and I'm a founder and director of Anomaly Labs. So this particular company it's in hardware testing, vehicle testing, IoT and industrial control systems, and I'm a security researcher as well in those fields. So I'm a trainer and speaker of conferences like Black Hat, ROOTCON, and ROOTCON as well. Yeah. So you can reach me on Twitter at the rate ROOTCON. And here's my security co-researcher, Nikhil. Hello guys, I'm Nikhil Gogan. I'm safety and security for automotive. I work for a year. I also presented a talk at ROOTCON, and now presenting about ROOTCON. Also have almost 10 years of experience automotive. Thanks, everyone. So today's agenda is what the role of security is mainly if we talk about automotive security, we call it as cyber security. So what's the cyber security roles in the cars or other vehicles? So we can say the automotive security, and we'll understand a little bit the briefing of the car canvas protocol. And we also see what are the different kind of attack vectors you can perform on the car network as well. We call it as a VCM module. And we'll go for why the ADS. This is the theme of this talk actually. So why we require ADS anomaly detection systems now in the automotive business. So after we can go for how we can implement those kind of what are those techniques to implement ADS anomaly detection systems for automotive and their working principles as well. So we'll show you the demo as well how we can reduce false positive alert in ADS. So as I say, nowadays if you see the cars are getting connected, they use V2X kind of technology. It's nothing but vehicle-to-vehicle communication or the cellular communication. Then you can say DSRC is one of the protocol they use for vehicle-to-X communication. So there are different kind of attack vectors introduced into its connectivity with the infrastructures. So some devices comes in the market, they call it as a TCU. So it's a telematic control unit. So what they actually connect with the manufacturer's cloud or other vendor's cloud, and from the vendor's cloud they connect with our mobile application or other web application. So that means when you guys send some signals, we call it a message, which can be a trigger, not exactly the trigger, so we can engine start and off, or start, or other you can say off as well, or other you can say stop the engine. Then you can open the trunk, you can handle the AC ventilation, certain ton of things. So why these devices coming in the picture now? So nowadays, so if you see the old cars, they are mostly are the manual. I'm talking about it's not intelligent enough. They are not smart. So for that purpose, third party. Like if you see in automotive sector, there are different kind of vendors like tier 1, tier 2. There are manufacturers. One guys are supplier, and the third party comes into the picture. And these third party guys come up with a different technology called as a telematic control unit, and that enhances the car. that enhance, and that becomes connected car nowadays. So once the your the you can say car is connected with the cloud, that becomes the risk comes to the picture. So ECU is nothing but our core brain or the you can say heart of the car. So who takes all decisions. So if something happens with the connected cars, it goes to brand agents of the particular manufacturers like the TL122 as well, and this is a risk to human being as well. So what exactly the CAN? CAN is introduced by Bosch in 19, I believe 86, and they come up with the CAN 1 and CAN 2. Then CAN 2.0 comes with a two different flavors, CAN A and CAN B. And this particular thing works on two-wire communication. They CAN high and CAN low. So CAN something that works on differential signaling, and it supports OBD2 port as well. So OBD2 is nothing but on-board diagnostic. So every nowadays ECU, the BCM as well are connected with the OBD now. And if you have good access to OBD, so you can see a lot of communication, even the EBS packets as well. So if it is without support, can be supported. So this is how the CAN frame looks like. So as I said, these are the differential signaling, and they have CAN high and CAN low. So if you see the arbitration ID, if you talk about the 2.0, CAN was 2.0 B, so it would be like the arbitration ID would be like 29 bit. Now here it's 11 bit. That means it's a CAN 2.0A frame. Then it comes to data length, then data and CRC frame and data frame. So what's the problem with the canvas? The canvas is again, it's not encrypted, it's plain text again. So there are different ways to encrypt those communications. I would say not encrypt. I would say it's a secure with the help of different techniques. You can use HSM model, gateways. So there are different ways to secure that. But the only thing is why nowadays people are coming into the picture, they are hacking cars because of that particular protocol. When in network, when they talk to each other, they actually broadcast the message, right? So there is no destination address or source address over here. So whatever they feel, whatever they have events, event trigger, they broadcast. So if you have two with you and if you connect the OB2 with the help of OB2 or other, if you connect it with the ECU, there is a lot of possibility you can see those informations or the CAN messages and you can play around. So where you can say be vulnerable. So there are different ways to attack those cameras. So first you can say DOS. Yeah. So DOS is nothing but if you have, let's say you have some ID and that ID is responsible for changing gears or different kind of events. So if you send the all zero payloads in the message, it becomes it creates a DOS. So it's really difficult to understand ECU what exactly the message is going on with the 000 data the payloads. So these kind of DOS you can create even if you go to if you're going in a hardware kind of attack. So you can say if you connect the CAN high and CAN low directly, you can say short circuit. So it will create a DOS attack as well. So firewalls is nothing but the attack where let's say there are consecutive message running in the network, and let's say they have the timeline between two alternative between two CAN messages would be like let's say it's 2 seconds. And firewalls attack it, you will have to decrease those time. So let's say I make it as a 1 second and after 1 second time I send the all messages. So what happened to the ECU? So my message will accept that particular ECU. So that becomes again different kind of attack. And there is a thing called packet payload modifications. Again, you can use it as a fuzzing. So you can modify those packets, or rather you can say kind of you can do UPS packet fuzzing as well. So you only need to modify those packets as per the whatever the information you got from the reverse engineering of entire CAN messages. Packet relay, yes, there are a lot of things you can do over the relay attacks. You can store entire packet information and you can deliver it to a particular ECU and you can see that a lot of events can happen. And let's say you guys have the gateway, right? Gateway, in that case, they automatically, sometimes they call it as a firewall as well. So in that case, the gateways are in the position that they can avoid those modified packets, these kind of attacks like DOS or firewalls attack. They are nothing but ADS, but they are gateways. But in that case, you can do some sort of right before attack. What we do actually, we save the legitimate you can say the messages. Once we save the legitimate message, after that we save the malformed packets. So this is called as the right after. And right before is like before sending legitimate message, we send malformed attacks and then send the legitimate messages. That can check the validity, or you can say the effectiveness of the gateway. There will be a lot of possibility you can bypass seeds which is stored into the ECU as well. So these kind of attacks you can perform, even these attacks you can perform in a car hacking village as well, which is hacking by Jaipur. And this is how because of these attacks, and then we are going to come into the picture like anomaly detection systems. Then we modify a lot. We tested a lot of different kind of attacks performed on our areas, and we try to reduce false positiveness. So Nikhil will be take care of this part, and I believe he'll do it. Thank you.
Wait.
Okay.
We're not going anywhere.
I think so is tradition, right?
Yeah, position.
Yeah.
Are you okay?
Yes. Why water?
Yes, that was the one.
You cannot guarantee for the limit. Please show me. Yeah, that's right. Oh my God.
Where, before you start, so you
No. Once you finish, then you can have it.
give it down.
Now,
That's where they go. See, now you feel better, right?
thanks, brother. Thanks, again, that you have this wonderful thing. Not that confident that I think so.
DEFCON, they do.
They do, okay. Thanks, I will actually try to explain a lot of things, and I'll just concentrate on the vacation part of it. I will try to explain you what types of attacks you have in the canvas. Okay? So, car is very complex device. It's having a lot of issues. You will never believe that in our microphones we have only one microcontroller. But if you go in the car, it has 150 to 200 microcontrollers. You see 150 phones actually resides in the car. So it's very, very complex and not so easy to explain everything, but we'll try to explain it as it is possible to you. Okay, so what it means anomaly detection system? Try to understand in terms of in a generic way. So what it does is actually compares the expected flow of information or expected with the actual one. What everything is going fine or not. So there are some CAN messages flow going on in the bus. So there are different numbers of CAN messages. Arun has explained earlier. Okay? And if this expected and actual both are same, then everything is fine. This is what they said. And if you have a mismatch of them, you will see at the right corner, it raises the alarm. So it detects it. If there is any mismatch in the communication happening between the issues. It is as good as if I try to explain in terms of you have let's say kind of a router and many phones or any devices are communicating. So you're just checking, nothing is going, nothing is a problem. The same way the CAN will also have. But we will see in the subsequent slides how this CAN works as well. Okay. Okay, one important aspect, why do we think that this is the best solution? We would have encryption, we have so many other types of security mechanisms available there. We can just encrypt the packets which is sent on the canvas, and that's it. Then it is as good as what the internet world is right now using. So the problem with the security or encryption, lot of payload, it includes a lot of data. And you see that in the car, we have a braking systems, we have a steering system, we have critical systems we have. Like this has to be processed and executed within a very short period of time, sometimes within 10 milliseconds of time, without losing the actual information. Otherwise, you people going in a car outside might be thinking that this controller will not work, it gets hacked, and then it's a problem, right? So we need as minimum as possible this information should be, and that's why the best. This may not be the best solution that you just encrypt the whole data with some security. Instead of that, we can go with this ADS. ADS doesn't do encryption. What it does, it checks actual data with the expected one. That's it. And if this things there is a mismatch, it takes the alarm, and we go to the state where we can make the car into the safe state. I'll explain it to you later. Second part is cost. I told you 150 to 200 ECUs controllers are there. So you have to modify all of them, and it requires a lot of cost. So this is the thing, an automotive world moves very slowly. If you want to, let's say, launch a car, maybe plane, and you have to start prepare 4 years back. This is the problem of automotive. They don't immediately launch it in the next segment. The reason being is reliability. They don't want the people sitting in the car feel unsafe. Like in the mobile, you can, and you just have a new patch, you restart, everything works. But for the car, it doesn't work like that. And that's the problem. That you need a cost, and also other solution needs many changes in the CAN network. Right now, you already have a robust design, you need to change that. That's also a problem. Okay, changing ECU system software is consuming automotive sector due to many compliances. So also many compliances. Okay, let's move to the next topic. Okay, now I would like to give you a brief how exactly it works. Everybody holds a car, right? At least understands the car how it works. So let's start with a simple thing. You have a light switch, a headlamp switch is there, and then this is a canvas. So whatever the lines are made, this is a canvas. The packets are transmitted from here, and it broadcasts everywhere. It goes to all these ECUs. So I'm calling it an ECU instead of controllers. But the body control module. So here, receives this packet, process it, and then send it back to the headlamp. Turn it on. So turn it on or turn it off. This is done everything on the canvas. At the same time, the brake sensor sends the information on the canvas again and has to go to the brake lamp, let's say. Okay, so this is a typical CAN network where everybody try to transmit the information with some kind of a time multiplexing type of thing. Okay? We will see in the next slide. Okay, yeah. Now, where this ADS fix? So where we fix this ADS? So we know that CAN bus is transmitted. The CAN bus consists of so much information. Now I've just shown something like lights and the red. Do you remember there are so many features you have? Like you have a steering, you have a wiper, you have an engine control unit, so many information. I found thousands of messages are transmitted on this one. So the ADS, so which is in the orange color box, sits on that bus. So it's try to monitor what's going on in the bus. It's try to check. So what it check? Okay. So what it exactly does is we what method we use here. Let me go to this slide first. Okay. Now we see this is a CAN transmission. How we talk them. This is a time, and there are three ECUs. So let's say brake ECU, some other light ECU or something like this, and these red boxes are the packets, CAN packets, and the numbers are written is the IDs of that particular packet. Okay, and some packets are transmitted with 1 second, some packets are transmitted with 5 milliseconds, some with 15. So it varies based on the type of information has to be transmitted and what is the criticalness of that particular message. It all varies, and that's why you have so much information on this bus. Okay, is it understandable? Can you raise a hand? Understandable? Thanks. Motivate me that I go further and try to say something more on that. Okay, let's go back to the slide. Now, how we can detect this? If you remember the previous slide, which was showing, we can detect that this message has to be transmitted every 1 second. So if we can check that this message it has to come in 1 second, then this ADS does the same thing. It actually checks, okay, packet number 03 came last time at this instant, and now I have to wait for 1 second. If it comes in between, okay, it means it's a problem. So it has to come in 1 second. Okay, so same way for the packet number 02, if it comes within 500 milliseconds, means with some tolerances, of course, then it's fine. And if it goes beyond or it comes early, it's also a problem. Okay, this is one type of mechanism which is we call it as a frequency detection. So we check the frequency of the packet. Okay? This is generally used by many car manufacturers to detect it, but they are not so much robust enough that they detect exactly which packet is going to come. Okay? So let's go here. The frequency there. So it checks the time between packets 03, how much it is. So ADS checks if the time between two packets as per the expected time. So if this is within the expected time, it's fine. If it is not within the expected time, it's a problem. Okay? So this is one type of mitigation, and they apply on the ADS. There are many. We will go one by one how it does it. Okay. The second mechanism is a filtering. So what it does, it knows that what are the possible messages are there on the bus. Some of them, like for example, 0503, okay, it learned last time that these were available, but the messages like 00FF, something like this, can be filtered out. So ADS checks if no unexpected packet is received on the bus. This is also it checks. So these are here 00 or FF. These are the unexpected packets. And this type of mechanism is called as a filter, which filters the packets which are expected. Okay? Hopefully you are understanding it. My intention is to make you aware of the basics of it. Of course, in the detailed level, you can go on the internet and search how this works. Also, in the car acting village, we have this demonstration how this can be detected. Now, this is a little bit more complex than the earlier two ones. What it checks, it's trying to really understand that after what digit the another digit comes. So earlier the message address was 03 and then it is 02. You will see that this is a one type of sequence. Again 02 to 05 is another sequence. You will see that on this side the sequence is repeated 03 to 02. Okay? So this is also one of the type of mechanism to detect any type of unexpected behavior is occurring. Somebody, as I was explained earlier, you can put a packet on that. Right? The bus is available, you put a packet here, and then the sequence is disturbed. And this is how the ADS detects the disturbed sequence as well. So ADS checks if the sequence is as per the expected sequence or not. So you will see that okay, if you compare with the Ethernet packets, you will say, oh come on, it's very difficult to understand at what time what packet comes and to make this analysis. It's very difficult. But yeah, I also understand the same thing, and that's why we have machine learning done. You cannot actually practice are going in a really fast way that and because so much data is present, we need some kind of machine learning. What we need is connect this box. Okay, right now we use the same ADAs to read the CAN messages from the network. Okay, learn the CAN message sequence, timing, filtering, and everything it learns, and then identify the sequence and timing between the messages. So it stores this information. But you will say, okay, when the car is stopped, it's different. When the car is starting, when it's having a different gear, it has maybe power supply problem. You're right. There could be a false positives, and that's why the learning time has to be improved. Okay, so that's what the Google is also doing for its learning based on the what part is how the autonomous car can work. And this is one type of approach, and of course the calculation and the analysis has to be done. Our approach is somehow different. What we try to do is we don't completely rely on this machine learning. We also have some specification that has to be in the areas as well. Okay, this is the learning phase of that ADS. Once this is learned, you can have stored the identified sequence and timing and check if the sequence and timing is matching with the CAN network or not. Okay. So this is the execution phase. This is the software which will reside into the ADS once it is figured into the car. And you keep on checking, and if we found a mismatch, it pays the alarm. Okay, you might be curious to know. Let's say my brake message has some problem. Somebody have compromised another ECU and try to put some brake related packet on that. And within 10 milliseconds, I have to brake. Okay, this is a problem. And this only raised the alarm, it does nothing, right? And we are working on not only detection part, but also how we can either prevent it or react to the safety. So I try to tell you one basic about CAN. If this CAN bus is off, okay, in the automotive, what we do when the CAN network completely off, the system, your car goes automatically to the safe mode. What the safe mode is like, if the brake are not working on the CAN network, there is a hardwired network is already present in your car. If your steering electronically is not powered, so let's say its power is removed, automatically turn over into a manual mode where the steering will be a little bit harder, but definitely it will go into the safe mode. So such a things can be done on the areas which can completely block the communication and all the issues which are reside on the car will enter into the section. So we call this is the safe mode of all the issues. Like if you're driving at the night, the headlamp will turn on automatically. Okay, so that's okay. So how we fit over here? Now we have seen the areas as well, and this is how we fit. then burst off in case of anomaly detection. This is one possibility, or you can raise alarm in case of anomaly detection. Sometimes it is not mission critical. At that time, you can just raise and show on the dashboard some problem occurred, or if it is critical information is there, then you can bust it off. Okay. Here, everything is clear. Okay. Nice. Okay, this is what we try to make some POC. We have speed transmitter issue. We try to transmit the speed from this particular issue, and this is a instrument cluster. We have an anomaly detection system also connected on the same network. Speed is going to transmit here. So we will show you demo how it works. Okay.
Sir, enjoyable. Sir, enjoyable po. Audio po. Cable.
Here, what I try to do is, learn. Uh, just few seconds. Okay, so this is ADS. Right now, it is blinking. It means it is not been configured yet. Okay, and now the next thing what I'm going to do is just to configure, learn what the network messages are there. And now the ECU has been learned over here. You will see that the blinking has been stopped. Okay, now you will see the transmitter ECU is trying to send the speed information, and it goes from 0 to 180 kilometer per hour, and again it comes back to the 180 kilometer per hour. This is a screen where you can see multiple messages coming on the bus. Now you'll see the LED is flashing. So how it's possible? Okay, so I'm trying to send this. Yeah, yeah. Okay, so yeah, this is a message. This is a malicious message. We are trying to translate on the bus, and whenever we try to translate the message, if you see the ID here, I don't know whether you can see, but this is 314, the same ID which is required for translating the speed information. Okay, and now can you? It's transmitted. You'll see that the ADS is able to detect that particular malicious message, and you will see that the speed is now toggling in between somewhere around 60 to 80, something like this. Okay. Okay. So that's basically a POC. Like you can able to detect a malicious message. We have executed this test on multiple attacks, which Arun has already stated, and we feel that this works good. But of course, it also needs a lot of improvement in this case. We have this transmitter is very constant, but in the car, generally we don't have such a constant information, and the learning phase has to be improved. you will see that the learning phase we just took around 5 seconds, 5 to 10 seconds, and within 5 to 10 seconds, if you are able to learn multiple packets. For the tasks, we might need to run for maybe 6 months or something like this to get the good performance and avoid any false positives. Okay, that's it. Thank you very much. So if you have any questions, we can take questions. Or,
Or like they could run wide or shot. They don't have questions that they can drop by.
yeah, so you can see our demo in the car hacking village. So you can go over there, you can play with it, and you see you can play with applying a lot of different kind of attacks, and you can see over there that the attacks get detected with the help of our proprietary algorithms. Okay. Excuse me, we have one question.
Oh yeah. Yeah, one.
You mentioned if we recognize an anomaly, we can go to a hardware option. Is
Yes.
that available
Yes,
now?
yes. So it depends based on the car. So some cars have the hardwire, some cars has another protocol, like lead protocol, select protocol, which is communicating the same information to the another AC. So it depends upon the car.
Well, yes, in industrial systems, we have safety systems, like there are standards there, so I don't know what the process equivalent.
Okay. For the safety standard, we use ISO 26262. This is the safety standard for the automotive car system. And for the security, it is J3061. So this is a guideline document provided for automotive security related work product creation and as well as for security testing. Questions?
Any more questions, guys? One more question. More questions? So, for those who have questions, you can feel free to approach the car hacking village. Aaron and Nikhil will be there, and well, they'll just be around. Feel free to approach them anytime. So,
Absolutely.
all right. So I think that's it. So thanks so much.
Thank you.
Aaron,
Thank you very much.